With lots of people talking about the future of spaceflight right now, we wanted to find out more about how plans are shaping up for building things on the moon or Mars.
And so today, we're talking to Madison Feehan, founder and CEO of Space Copy, an international lunar manufacturing company. And in my opinion, this is one of the best interviews we've ever done.
How are we doing? We love feedback. Tell us what you think on our social media pages at Space and Things Podcast on Threads, Instagram, and Facebook, via the contact form on our website, or by leaving a review on your podcast platform.
And please consider joining us on patreon.com/Space and Things. But right now, it's time for episode 202 of the Space and Things podcast.
You're listening to Space and Things with Emily Carney and Dave Giles.
I'm Emily Carney.
And I'm Dave Giles, and welcome to episode 202 of our podcast. How are you doing, Emily?
Great. Things are good here. How you doing, Dave?
Good, thanks. How did the Skylab podcast go on Friday?
It went beautifully. The interview went beautifully. It was just my internet is not... I need to get a new ISP, honestly. My signal was not great, so I was having excruciating signal issues during it. But I do want to add, we did break our goal. We raised over $1,300,
wow,
which is excellent. Our goal was 1,000, so yeah, we did it. Thank you to everybody who supported that fundraiser and donated to us. We really appreciate it. Some of you got some really cool prizes as well.
Do you know if it's still something people can watch now, or was it live, one and done?
I believe John is editing it, so
right,
he's going to come out with that soon. John is on I think John is on vacation right now. He's in Colorado, so he's going to edit it, put it all together, and it'll be something for everybody to watch. Yeah,
amazing.
Yeah, it's not a one and done.
Okay, well, when that's ready to go, I'll make sure we'll post that link in all our social spaces so that people can see that. Right, let's crack on with this week's main feature. Today, we're talking about how to make things on the moon or Mars and how to turn your ideas for spaceflight into amazing businesses.
And to do this, we're joined by Madison Feehan, the founder and CEO of Space Copy. As an early career professional based in Edmonton, Canada, with a background in advanced lunar instrument development for NASA's planetary science, heliophysics, and astrophysics divisions, Madison's initiatives are focused towards combining deep tech development for in situ resource utilization with entrepreneurship. Madison's background is based in commerce, and she holds a Harvard Business School certification in entrepreneurship and innovation in conjunction with her ongoing studies in international business.
Madison seamlessly merges scientific expertise with a keen business acumen and stands at the intersection of space science, entrepreneurship, and STEM education. As the leader of Space Copy, an international lunar manufacturing company, and co-founder and CFO of Moon Trades, a lunar mining and robotics startup, Madison leads groundbreaking initiative driving innovation in space technology and fostering accessible STEM education, as well as serving as the G100 Region Chair of Space Technology and Aviation for the province of Alberta. Her commitment to shaping foreign policies for small businesses in STEM through her volunteer work with consortiums, including the United Nations, and mentoring others in science, reflects her dedication to propelling the space industry forward through collaboration and visionary leadership.
We recorded this last week, and Dave and I were texting about it for hours afterwards. In our opinion, this is really one of our best interviews to date, so we hope that you enjoy it as much as we did. Play the tape, Dave.
Sure.
It's time to shake off a case of the Thursdays and listen to Space and Things with Emily Carney and Dave Giles.
So, welcome, Madison. Thank you so much for joining us. So, first things first, was there anything that spurred your interest in spaceflight, or was it an offshoot from other areas of expertise?
Interesting question. And thank you so much, Emily, for hosting me here today. It's a pleasure to be here. With regards to my journey in aerospace, I would have to say that the catalyst for me was just kind of diving into what is planetary science. It's a journey that started, I'd say, around 7 or 8 years ago now. And I was just a student who was mildly curious about STEM and the initiative of going to space. And I had taken some education in planetary science and gotten to know about what it takes to live on the moon and what it takes to live on Mars. And it was something that really piqued my curiosity. And I think it's been growing ever since.
So your company, Space Copy, is working on some innovative technologies that will be useful on the moon and other interplanetary surfaces such as Mars. And you just talked a little bit about that and how that sort of molded your aerospace career. So what was the progression from, hey, this is a cool idea, to starting a space company?
So let me first give you a little bit of a backstory about Space Copy. So we're an additive manufacturing company. We're based in the United States and Canada. And essentially, we are developing these novel 3D printing systems that are able to take any kind of soil or sand, say off the surface of the moon, or even here on Earth in the desert, taking sand and converting that into a feedstock that allows you to build infrastructure in these really extreme environments. So anything from habitats for astronauts to lunar launch pads to precision tool fabrication, that's kind of our main domain. With regards to the inspiration, though, behind starting the company, I'd have to credit my time at NASA. I've spent 5 years as a non-civil servant working in planetary science, heliophysics, and astrophysics. So getting a well-rounded knowledge of what's going on in the aerospace industry from that kind of government standpoint. And during my tenure there, I definitely saw that there was a gap between commercial industry and government when it came to inhabiting space and staying there on a long-term basis. And trying to close that technology gap involves creating hardware solutions that are dual focus, that have uses on Earth and in space.
Yeah.
And for me, I found that niche to be 3D printing. So being able to communicate why we need to build infrastructure in space is one thing, but being able to actually go out there and do it and pioneer the technology that it takes to build something of that magnitude is something that I didn't see very prevalent in the industry. And I thought to myself, that is a challenge that I want to pursue.
Absolutely. I love this. This is such a great idea. When you first came up with the idea of starting the business, actually getting going, did you find that you had good support in the industry? Was it a bit of a challenge? Describe those early days.
Good question, Dave. And thank you for that. I would say that it's an even balance. There was a lot of support. I tend to think that the aerospace industry itself is quite a supportive ecosystem. There's a lot of people who are out there trying to help each other and looking to collaborate and partner together, which, I love how that fostering of relationships has kind of come into its own in this industry. But most certainly, and I think that this goes with a bit of a precedent of aiming to tackle something that's so intensive and really, really challenging in its own regard, there's a stigma to some extent in the aerospace industry about what's acceptable. How challenging is it to build certain technologies? What's the payoff? What's the unit economic benefit of actually being able to bring that technology into fruition? So as much support as there is from scientists and the whole STEM community, I think that there's kind of an opposite side to this. Primarily, I'd say maybe from the funding side of things, where there's a bit of a stagnancy in trying to connect the technology to the funding and vice versa. I think at the end of the day, having the good storytelling skills and really putting yourself out there, trying to find those right connections and communicate that value proposition is a way to break down those barriers. But definitely, industry challenges are something I've experienced.
You've touched a little bit about industry connections and things like that. So already Space Copy has connections to space agencies such as NASA. I hate saying that, that's kind of the big cheese of space agencies, and the Canadian Space Agency as well. How do you think your company's technologies can aid in these entities that are so enmeshed with governments? Obviously NASA is from the government, CSA is the Canadian government. And is that a challenge?
Oh, most certainly. I definitely say that when we're in the aerospace industry, the most complicated thing that you can do is to start a business that sells to the government, because of the fact that you're going through red tape, you're going through all of these different processes that you have to go through in order to actually serve the defense ecosystem or the space ecosystem as a client in government. As a proud Canadian who has worked for NASA, who has seen kind of the inside of how that works, and then also in my own home country, seeing how that space ecosystem works with, say, the Department of National Defense, I'd say it's a very delicate balance between how those different frameworks interact with each other, how those agencies coincide, and then trying to find those gap areas where industry can start to contract their services out there. So Space Copy, we're split between B2B and B2G services. So we sell to clients in private industry, but we also have our main offering, which is kind of more defense and government aerospace oriented. And definitely there are challenges, roadblocks, red tape anywhere you go. For myself, it's definitely just in getting that contract secured, fulfilling those requirements, making sure that we're compliant with things like ITAR regulations or CFIUS, all those kind of keywords that the space companies, they don't like to hear so much, but we have to be compliant to it. And that involves a lot of due diligence on our part. And keeping that regard in mind, I'd say that just continuously, keeping up to date with what these space agencies are doing, how international policy is starting to ebb and flow within those areas is the only thing that is allowing us to survive in that ecosystem.
So I want to go back to the start of the company again. So you have the idea. What's the first thing you then do before you set up the company? Or maybe maybe getting the name sorted and putting the company structure in place is first. But did you have to sound out support and get other people's, I don't want to say approval, but opinions first? What are the steps between idea and starting the company?
So we started Space Copy just under 2 years ago now. And when we were in that early formulation stage, I'd originally actually come up with a concept for 3D printing on Mars back in around 2017. And I pitched that idea to NASA. And although this is something that they were kind of passively looking at and researching, in fact, additive manufacturing is something that's been looked at for space since 1980. So it's going on about 44 years. But the concept itself, it wasn't taken all that seriously at the time. There was still a lot of proof of concept and de-risking that needed to be worked out. So originally, the idea kind of sat dormant. Now, it was back around 2022 that I picked up the idea again on a more serious basis after completing the NASA Space Apps Challenge competition, which is just an open science platform for young researchers and students to collaborate and create ideas that solve technology gaps for space. And the project that year was about 3D printing in space, specifically Mars, which of course was my original concept back in the day. So I got to apply that knowledge specifically to that project. And it just kind of sparked something in me to say, how difficult would it be to ascertain a similar technology development on the moon? We're talking about Artemis, we're talking about going back there and establishing the permanent basis. And without infrastructure, where are you really? Yeah. So it felt like just kind of this logical solution here. And I started doing some research. I looked at the NASA Planetary Decadal Survey. I looked at the Artemis Accords and the objectives that came from that. I also looked at the NASA Moon to Mars objectives and something called the In Situ Resource Utilization Market Gap Report. These are all documents that were created by the US government, also the United Nations, to kind of coalesce all the different areas of space technology hardware development that needed to occur in order to catalyze Artemis. And I saw that infrastructure through 3D printing of local materials was actually a big priority. And it was the first time that I saw that actually being recognized in cemented documentation.
Wow, yeah.
So I went out, I started having some conversations with subject matter experts, people who are planetary geologists, for example, people who are in the additive manufacturing industry, both here on Earth for things like metal and ceramic manufacturing, and then those who are kind of the earlier stage pioneers in looking at 3D printing in space. And we did have a benefit. We had people like Maiden Space, who sent up a 3D printer to the International Space Station in 2014. So there was a bit of proof of concept that kind of helped us catalyze the support that we needed. And I would say just through having those conversations, especially in the early, probably first 6 months, as we were starting to organize the company, really allowed us to say that we're doing something that's meaningful and purposeful. So we translated that same energy into a startup accelerator program. We went through the motions of starting up the company, getting everything together. and then kind of started to catalyze on this need that we now knew was present.
Now, as you said, a 3D printer was sent to the International Space Station, and you're looking more specifically at putting it on the moon and Mars, where there is an element of gravity. Is that a complete different concept than the 3D printer that went to the International Space Station? In terms of the technology, how much easier is it to 3D print when there is an element of gravity versus no gravity?
Oh my gosh, this is such a compelling question, and there's so much science to kind of break down into that. I would say that it's got its challenges and its benefits. So first, let me kind of walk you through the lunar environment as it compares to low Earth orbit or even Earth, if we're doing a little bit of comparison. So on the moon, first of all, we're operating in 16G, as you know. So we've got the reduced gravity component, but there's still enough pull to keep things cemented down on the lunar surface, provided there's enough weight. There's a couple of other things, though, that we really need to take into consideration when we're looking at 3D printing in space. Those factors being temperature extremes, thermal gradients that are operating outside of our 3D printer. So the lunar day and night cycle with temperatures going down to, say, negative 150 Celsius, and then back up again to its positive conversant, maybe positive 150. Operating in areas that are close to permanently shadowed regions and seeing how different effects of that occur. And then the other kind of factors that I'm thinking about, solar radiation,
of course,
caused from plasma, space weathering, charging the regolith particles up there and actually getting that dust to stick to every single piece of equipment that you could possibly land in space. These are all things that we're taking into consideration, where we're looking at also kind of the non-spoken about things like moonquakes, micrometeorite impact. And you know what? It's a really delicate balance of figuring out how to mitigate against these environmental challenges. But strangely enough, and to answer your question about comparing microgravity on the International Space Station to lunar gravity, we are operating with what I like to consider a semi-benefit. Of course, there's the issue of, say, particulate flotation. We don't want regolith rising up and getting, scratched up in the optics of our 3D printer, causing things to break down and have a shorter lifespan. But we do have a couple of benefits, and that is especially when it comes to extrusion type of 3D printing. When you're looking at printing in a reduced gravity environment that still has a little bit of gravitational pull, like the lunar surface, what you're doing is actually when you're creating filament that's about to be extruded out for 3D printing, that kind of reduced gravity environment prevents a lot of clogging that's going on at the nozzle of the 3D printer, because it's essentially allowing that powder to flow through the filament and go through that extruder, go down onto the powder bed, and be a little bit more, shall I say, well-suited for 3D printing, at least in the space environment, because there is some degree of gravitation, but you're also having that increased flowability that you wouldn't have in standard conditions on Earth. So I do say that there's some pros to it. There's some cons to it as well, with just what's going on outside the 3D printer. But looking at all these different factors is not only really, really intriguing, but it presents a very interesting challenge for us to overcome. And that's something that I love to embark on.
Awesome. So the idea of manufacturing space infrastructure to some might seem far-fetched, especially in the context of utilizing, other worlds like, the moon and Mars and things like that. It's been an idea that's been tossed around since, for a very long time, particularly probably since the 1970s. So what's your case for, you've already kind of talked about it, but what's your case for off-world sampling and infrastructure? And do you think other companies might follow suit in that direction?
Oh, absolutely. I mean, we're building the space economy. And something that I always like to work into any kind of speeches that I give, or promoting what we're doing at Space Copy to a larger audience and client base, is all of us right now who are living right here in this moment, in this generation of Artemis, we are all setting the precedent of what the future of space is going to look like. So as kind of guests within that realm, within that economy, as it's starting to grow, as it's starting to manifest, we have this opportunity to really hone in on what we want that ecosystem to look like. And there's, I think, a very good relationship, a very symbiotic one, if you will, between mining and infrastructure. And it is true here on Earth. It's going to be true in space, extracting resources, using them for something tangible like oxygen extraction, getting water ice out of the polar ice caps. I mean, Artemis is targeted towards the South Pole, so we have an abundance of resources that are nearby. I'll give you an example. So if we're doing 3D printing on the lunar surface, ironically enough, when we're melting down that lunar regolith and we're turning it into, say, a precision tool to repair a rover, what's happening during that melting process is just kind of as a byproduct of heating up that material, it's releasing oxygen particles into the printing chamber as it's doing so. Can you imagine if you were able to capture that resource and use it towards EVAs and lunar habitats being able to sustain oxygen with in situ resources? And, you just kind of got to come back to this circular kind of economy wherein you're doing this kind of infrastructure, manufacturing, construction, excavation, mining, and they all work in process with each other. And I think it's just really at the end of the day, looking very strategically about what you're sending to space, what it's doing when it's up there, and then figuring out ways where you can actually kind of meet subsystem gaps in between those. So if you're sending up a technology that's designed to do one thing, you might end up having a dual focus that allows you to have even more capabilities than you originally anticipated. And I think for the lunar economy especially, when we have a limited capacity and how much mass and weight that we can send up at a particular time, looking for technology that meets those criteria and allows you to have like a multi-purpose benefit to having it up there is really what's going to catalyze that space economy and start to reduce some of that stigma around whether or not we can make it feasible in the long term.
Yeah, this is really blowing my mind. I love it. I absolutely love it. Now, how do you test this kind of technology? If you're looking at taking a printer to the moon, how can you test it in Earth conditions?
Well, there's a variety of ways that we can go about this. I'll give you the kind of high-level scientist answer, which is put it in a vacuum chamber and throw rocks at it and see if it survives. Aside from that, though, if we're looking from a very technical merit point of view, there's so many abundance of analog testing facilities throughout the world on a global basis. Of course, there's plenty in the United States where that space ecosystem is very prevalent, but primarily in kind of some of the focus areas like the Mojave Desert, for example, is a great lunar proving ground, as we call it. Basically, you drive a piece of hardware out into the middle of the desert and you simulate as close conditions as you can get. Of course, there's certain situations where humidity and weather makes that not so great of a testing site, wherein you have to go back into the laboratory. I'll say, for example, there's places like in Florida, there's great testing laboratory facilities coming out of Kennedy Swamp Works. If you're thinking on a more international scale, the government of Luxembourg has invested pretty heavily in developing out analog testing facilities. So is the government of Poland, actually. There's all these different kind of workshops, laboratories, secret areas up in the forest that people don't talk about unless you're in this domain, where they actually have big chambers that are filled up with simulated regolith that is meant to be accurate to what was recovered during the Apollo era. And you can stick hardware in there. You can stick it under vacuum conditions, or you can just operate it under like standard ambient temperature and pressure. And you can print around, you can drive it around if it's something that's mobile, and you can really just kind of get a feel for how that's going to operate. And I just love to see that, because not only are we working out some of those barriers before we get to space, but the enhanced capabilities that are coming up, and especially in the last, say, 5 or 10 years, have really transformed themselves. Now we're able to electrostatically charge the plasma and create ionic charges between regolith particles, for example, that can simulate the dust sticking to different machines. And then you can apply coatings to those to try and repel the dust and see, what's working, what's not working, what's going to impact your system's abilities to function, what's not. And yeah, I'd say just looking at what's currently available and what's starting to really formulate, at least for space copy, these are the kind of criteria that we're looking to overcome. sticking our 3D printer in those kind of analog conditions, under vacuum conditions, seeing what's working, what's not. And that's the really only way that we can get that close approximation without actually having to send something into orbit.
And how far away from sending something into space are you?
I always like to say that's a bit of an abstract question. So we're in research and development right now. We are kind of in this juxtaposition between technology readiness level 3 and 4. So we're going through that valley of death phase right now, where we're trying to suss out each one of our subsystem components and see what we can do to optimize it before we start integrating it into a single MVP prototype. But I would like to conservatively say that it would be nice to have something going up on an ISS national lab trip, or even a little flyby to the lunar surface somewhere in the later 2020s. So coinciding with Artemis 3, Artemis 4 kind of timelines, when they're starting to send people to space kind of on a temporary basis. They're going to be sending them in kind of like 1 week increments per year to build up their capacity and get them tolerant to living on the lunar surface. That's around the timeline that we're looking to have something stationed up there.
This is incredible. This is amazing.
So you're a woman leader of a space company. Aerospace has thankfully grown more diverse throughout the decades, and we're seeing more women in charge all around. So do you have any advice you'd like to give to young women, perhaps in high school or college, who might want to start their own aerospace venture?
Oh, absolutely. This is one of my favorite topics to discuss, honestly. I was in the kind of junior high to high school area when I started really having an innate focus on aerospace and STEM, and stepping into this industry as an early career professional, as somebody who's still kind of early in the game and considerably young in this industry. Definitely seen some stigma around sexism and ageism. When you think about this collectively, women in STEM make up around 18% of the workforce. So though we are growing in our ranks, it's really only about 1 in 6. And I think that a big responsibility to that is just not really communicating what opportunities there are for women in space, and really kind of catalyzing on the fact that we can do it. We just need that proper support. So if there's something that I can always advise to young girls who want to get into STEM, who want to get into space, is to be persistent, have perseverance, have motivation, go out there and seek knowledge. I always say education is such a top priority. Knowledge is power. And going out there and looking for, I'd say, technology gaps as well that the space industry is looking to solve. Find something that really piques your interest and start diving into it. Create a niche specialization for yourself. Try to build your post-secondary education around something that is impassioning to you. And in coalescence with that, look for work opportunities, allow you to intern for companies that are doing things that are along your area of interest. Engage with space agencies, attend webinars and industry events, and join online consortiums that are having these kind of conversations that revolve around space technology. I think that the industry fosters a lot of collaboration, and it can be quite friendly if you're out there and you're looking for the right people. So I just want to kind of come back to this message of it is possible. You can do it. You just have to put yourself out there and be persistent and motivated enough to keep that journey going, and you're pretty much bound to find success.
Fantastic. I have one other thing which has come up here. You said just there, knowledge is power, and I couldn't agree more. I think it really is. And what struck me throughout this interview is that you have knowledge not just of the technology side of things, but also of how to run a business and how the business setup works. So which do you actually think is more valuable in terms of getting involved in the space industry? Do you think it's more important to have a really solid understanding of business infrastructure, or to really focus on the science side of it or the technology side of it? Or do you just have to do both? And did you learn one on the way, or did they both come through at the same time?
Oh my gosh, this is the one kind of, I think, burning question in the space industry is, do you go on the business side of things? Do you go on the technical side of things? Or do you really just try to push yourself to do both? I myself pushed to do both, but I've seen the side where you either go just solely technical or you go solely in business. And I think that depends a lot on what your career trajectory is meant to be. If
Right.
you're looking at kind of operating in the private industry ecosystem, then I would definitely recommend getting your business development skills into check, seeing what it takes to run a business. I personally got my education background. I'm getting a commerce degree right now with a specialization in international business and entrepreneurship. But I also have a background in business, innovation, entrepreneurship from Harvard Business School. And during my tenure there, I learned a lot about the theory of disruptive strategy and what you would kind of consider to be a blanket solution for any kind of business really, really seems to hit home when it comes to space and science, because essentially that industry is built on disrupting previous technologies and looking for solutions to technology gaps. So in that regard, I can say that having a commerce background for me personally has been invaluable. I used to joke that in the early days of starting up Space Copy, we were going through many different business accelerators with Techstars, Singapore Management University, and the whole bunch. I used to say that it's quite funny that I'm applying everything that I just learned in business school towards this venture, or something that's being talked about in a master class about how to start a business is something that I was just attending a lecture on the previous week. And I think just kind of like working together in those ecosystems, it's very, very important to have that business knowledge, especially if you're embarking in entrepreneurship or just being part of any kind of private industry side of space. I'll also take this now kind of from the opposite side, which is the technical side of things, which if you're looking at it is honestly, I'd say the bigger challenge, because you're getting into the real depths and diving deep into, I'd say, the never-ending pit of knowledge when it comes to how to operate technology in space. And you almost have to choose your niches around what you're trying to master. Of course, I went into the 3D printing and additive manufacturing side. So a lot of the knowledge along the way was centered around geology, material science, how 3D printing works, how monitoring systems and spectroscopy works in regards to planetary science. And I never had a classical education in anything that was technical. I started to get that along the way, but I certainly didn't have that when I got started. I learned all of that knowledge through talking with subject matter experts, through having conversations with scientists at conferences, and through my work experience at NASA. I knew basically very, very minute information when I showed up there at NASA one day when I was 16, saying, okay, let's talk about spectroscopy for the moon. What's that? And having to sit in a room with scientists who had, say, 40 years of career experience in that field, it gave me a very good opportunity to dive into these niches and really understand how these technologies work together. And just to kind of bring it back home to what you were saying about balancing business and balancing technical skills, I honestly think wholeheartedly that the industry could be optimized in a sense by having an even balance between both. We're looking at the economic side of why we invest in space and why it's important and how that's going to help humanity. And then we're looking at the science side of how these benefits can be translated back to a dual focus on Earth. And conversely, how do we solve some of the science gaps? And we wouldn't be able to do either of these systems without each other. So really communicating the value proposition of having both of those skills, going out there, learning a little bit about one or the other if you're not well versed in them, I think would really, really be beneficial to the space industry if more people started to adopt that mindset.
Well, thank you very much. This has been one of my favorite interviews we have done.
Yes, this is fascinating.
You are an extremely impressive individual, and I have been blown away by this interview. So thank you so much for joining us and inspiring us. I now want to go and do a whole load of stuff with my evening just from listening to this interview. So thank you so very much for joining us and spending some time with us.
Yes, thank you.
Absolutely. Thank you so much. My pleasure.
Where mispronunciation is entertainment. It's Space and Things.
Wow, that was just incredible. As we said earlier in the podcast, I really think this was one of our best interviews we've ever done. It was just incredible. Dave is going to roll his eyes into the back of his head so far now. He'll see his brain.
I know what's coming.
He knows it's coming. He knows it's coming. Y'all know it. Anyone who's listening can feel it coming. So I'm just going to say it.
For those of you who had Emily mentioning Gerard K. O'Neill on your Space and Things bingo card, you can now tick it off.
I feel like the promise that O'Neill delivered in the 70s, like, hey, we're going to have on planet and on the moon, we're going to have manufacturing resources and stuff like that. I feel like that's finally, now it's being realized, like, for real. Like, it's being realized in a serious manner. I think back then, a lot of issues were, they were limited by funds, obviously, and they were limited by the technology during the 1970s, probably not the greatest, but now we have 3D printing.
I wonder whether 3D printing was something that he would have ever thought of. Whether that was something that when he was writing, it was something he was thinking of. Obviously, he realized that regolith was something you could use to make things with, but I wonder if he'd ever thought that side of it, whether he was that much of a visionary. Do you know?
I don't recall. That is an awesome question. I would have to look because he has a couple of books, The High Frontier and 2081, that talk a lot about future technologies. And a few of them are kind of cheesy in retrospect, but we have them in some form now. But I don't recall him really predicting 3D printing like as it is now. He did predict that we would use materials from other worlds to maybe make things. That's, I think, about as close as he got. But he never said, 3D printing or anything like that. He did predict the Apple Watch, that kind of technology, and having like automated services in your house. Like, I don't want to say the word because I have it and I don't want everything in the house to come on and start working.
Hey Siri, play Space and Things.
Exactly. Yeah. He sort of predicted like automated technology in the homes and things like that. But obviously I can't talk about it because I don't want the TV to come on or something like that. Seriously, I don't think he predicted 3D printing as it is now. Like, he never said 3D printing or anything like that. No, but it is absolutely incredible. I think his promise is starting to get realized in ways he probably didn't predict or exactly nail, which can be forgiven. I mean, this is almost 50
years ago.
Yeah. So he can be forgiven for not really being able to see that far in the future, because honestly, with me, 3D printing to me is still pretty incredible. I have a couple of 3D printed items and I'm like, this is nuts. Like, this is really, and I love how it's fabricated in one piece because that prevents manufacturing defects and stuff like that. That can prevent manufacturing defects. And I love that. I think that's really cool. So I'm looking at it from the perspective of, let's fast forward and you're on the moon, right? Or in space and you need something, but you can't exactly just call Earth and be like, yo, I need this. Can you guys send a spaceship up? Like, that's not going to be like overnight FedEx. You're not gonna, we may not have that capability yet by that point, and if you need something, you could probably just make it yourself. That's pretty amazing. And I think that's something as far as sustainability goes, you're not going to be able to go to Target unless Target starts opening stores on the moon, which would be pretty badass. Then I would go there. You can't exactly order things from a catalog, unfortunately. It'd be nice, but I'm sure the first moon dwellers are not going to have that capability whatsoever. So to have this capability in place and to have a company that's thinking about it is awesome. I'm sorry, I over-enthused way too much, but that was so exciting to hear.
There was a few things that struck me. Number one, I love how she spoke about it being a technology that has a dual focus. So it's something that you can use on the Earth as well. Weirdly, Emily's wearing a t-shirt about deserts right now because you could go into the desert and get a load of sand, throw it in your 3D printer and build something. And I think that can solve us problems as well in terms of resources on this planet. So I like how she said it's really important when we're doing space technology that we try and have a dual focus. What can we do that's going to benefit us in space that can also be used on the ground as well? And I thought that was really interesting. It's something we've kind of spoken about a lot, about the applications of space technology. And sometimes you don't know exactly how it's going to impact the Earth, something that's being done in space. But if it's a piece of technology that can be used in space and on Earth, it clearly can help Earth. So it's great to have that dual focus, and I really like that she spoke about that.
Yeah, exactly.
Secondly, what I found amazing was just Madison in general.
Yeah, Yes, she's freaking awesome.
Right?
Yeah.
Such an incredibly driven person with a brain doing 800 things at once. And look what she's achieving. It's amazing. And I like that when we spoke to her about whether it's more important to have a focus on business or on your technology, she was like, you need to have both. Well, you don't need to, but she, in her opinion, do both. And I love that. And it's weird. We look at astronauts, don't we? You and I have said this before. When you look at astronauts and their CVs, which are really incredible, and they've got multiple degrees, and they're really good at lots of different things. Well, Madison is that as well, but she doesn't necessarily tick the things that they're looking for for a NASA astronaut at the moment.
Yeah,
but you can see how maybe we didn't ask her whether she'd be interested in this, but you can see how someone who can achieve that much and is thinking that laterally about things is exactly the kind of person, as space opens up, you would want involved in the space industry, whether that's on the ground or in space itself. So I just thought she was one of the most magnificent people we have interviewed, and she came across so well. Just such a delight to talk to, and she could tell a story as well. So you could tell the story of what she was trying to do and why she was trying to do it. And I think that's the other issue we've spoken about with space and the general perception of space, is that we don't have enough good storytellers.
Yeah.
So yes, they're my two big takeaways from this interview: the idea of having a dual focus, and just how wonderful Madison is, and how such an incredibly intelligent and able person she is, and how amazing it is that we have her working in the space industry.
Yeah, and just very determined and very focused. You know, I love that, because and
inspirational.
Yeah, and very inspirational as well. You know, I just loved it. I thought it was it was among my favorite interviews on the show, and we've done hundreds of interviews now, which is wild.
Yeah.
But yeah, it was definitely one of my favorite interviews, just because it was so forward thinking, and she is a very inspirational figure. We're going to go to the moon. We're going to go to deep space, but how do we live there? You know, we're starting to think about that. We weren't thinking about that 40, 50 years ago. It was more like, yeah, let's go to the moon and just collect some rocks and come home.
Yeah.
Now we're thinking, okay, we might want to stay there for a while just to explore see what there is there, see what kind of resources we have. And it's good that people like her are so visionary and are really thinking intensely about this and the things we're going to need there. I love it. I think it's incredible. You know, between some of the other guests growing things out of lunar regolith and Madison, things look very positive for that. You know, I really believe that. Yeah. I believe, hopefully, I'm not trying to be morbid. I'm hoping I'll be able to see it, but I'm hoping before I leave the earth, we're going to see people there, and that's going to be really neat. That's going to be really neat. We're going to see people living there, which is going to be wild.
Yep. So as always, if you want to know more about Madison and Space Copy, then head over to the show notes, which you can find by clicking in the link in the description of this podcast, or just head over to spaceandthingspodcast.com.
Better than eating broccoli, it's Space and Things.
So, Emily, what has caught your eye in spaceflight this week?
Yes, well, what's caught my eye this week is actually the end of the proposed end of a mission. The spacecraft NEOWISE, which is an asteroid hunter, and it's an acronym for Near Earth Object Wide Field Infrared Survey Explorer. Say that 10 times very quick. It has been that I almost stumbled on it. I was like, oh God, that's a lot of words. That's too many words. It's been up for 14 years now. And I guess the next mission will be called the NEO Surveyor, which is Near Earth Object Surveyor, much kinder to the palate than the last one. I'm just kidding. But NEOWISE is going to be deorbited soon, I believe. So the spacecraft is going to re-enter. It does not have a propulsion system, so it's not going to be able to keep itself in orbit. And as we know, we have had an insane solar cycle the last few months. So we are approaching solar maximum. So this is going to pull a Skylab on NEOWISE, and it's going to come back. So on July 31st, it will perform its last survey, and then it'll be put in hibernation mode on August 8th. This is according to an article from space.com. So NEOWISE, it's operated for 14 years, and it's basically, according to space.com, it's been in low Earth orbit. It's made 1.45 million infrared measurements over 44,000 objects in the solar system. And it is also observed, according to the article, more than 3,000 near-Earth objects. So really, it was one of the first-line spacecraft in programs in in monitoring things that could perhaps hit the Earth and hurt us. And like I said, they're going to send up another spacecraft in 2027 to mitigate this risk, hopefully, and at least let us know that there is a risk. And I think it's important. We've talked about planetary defense on this show before. We've talked about DART. We've also talked to Rusty Schweikert, who is, he's an Apollo astronaut, but he's still very much invested in this kind of thing, which I think is awesome. He's looking very much forward in the future to that. So, yeah, it'll be sort of the end of an era, but they're going to put another spacecraft up that will hopefully do similar things and keep the same observations. So, Neil Wise, it was nice to know you, but
ta-da for now.
Toodaloo. Yeah, see ya. Anyway, has anything caught your eye this week, Dave?
Yes, it has. The debut launch of Europe's Ariane 6 rocket, which took off on July the 9th from French Guiana. This has been a much delayed program. It was supposed to overlap the Ariane 5 before it went into retirement. It had its last flight in 2023. Unfortunately, because of things like COVID and then the war in Ukraine, it was heavily delayed. But it went up and it was a good launch. So that's great news for Europe. It actually will be quite competitive. Even though it's not a reusable rocket, it's quite competitive for European customers to use due to the fact that it's a heavily subsidized rocket by the ESA member states. Which means that the actual cost per launch will be higher on the Falcon 9 compared to what Ariane 6 customers are paying, because the customers won't have to pay the full amount, which is certainly interesting economically. They decided not to design a fully reusable or partially reusable rocket because this rocket's probably only going to be used up to 10 times a year. It's going to take a while to get to that point. But it does currently have about 30 flights booked in, which is good news. So we'll see how it pans out. But good news. This is a rocket launched from French Guiana that gives the European Space Agency their own launch capability.
Absolutely, yeah. And I'm excited. I hope someday in my life, it's a bit of a trip for me because I would have to fly through. I've actually priced it out, and I've actually done like a travel itinerary, and it's a little pricey and it's a little far for me because I would have to fly through Paris. There's no direct route. I would love to see one of them launches from French Guiana someday. That would be awesome.
Yeah, right.
That would be cool. Rumble in the jungle. That would be awesome. Yeah.
As always, articles about what Emily and I have spoke to will be in the show notes, and I told you how to find them earlier, so I'm not doing it again. Right. Let's move on.
Just a vehicle for space memes. It's Space and Things.
That's it for this week. We are very much into our next round of planning, so hopefully we'll have some big announcement over the next few weeks on our Patreon page. Signing up to Patreon means you're the first to know about our future guests, and you can submit questions for them as well. It's just one of the perks. Another is our monthly prize draw, which we've just done today. So if you're a member, check this week's video to find out if you've won. And you can sign up and find out more by heading over to patreon.com/space and things.
Thanks for listening and for all your support. We really do appreciate it. We'll be back next week for more Space and Things, but don't forget, in space, no one can hear you meme.
Things in space, space and things. Okay.